Hello there, so what have we got today? We have got one of the best of all biscuits, if not the best ever. I think we might have reviewed this once before, but it's always worth another crack. It's the good old chocolate hobnob, folks. Yeah, the chocolate hobnob, which is, well, you can't eat a whole pack in one go unless you're really hungry. And the nice thing about them is it's a bit like having breakfast, but then you've got the chocolate on top. And the normal hobnob, don't say anything against it, but it can leave your throat a little dry. So that chocolate just helps to smooth that down. We've got today, it's not going to take too long, the probability with tree diagrams. You've done that before at GCSE, and it's not much trickier, to be honest. So let's have a look and see how we go. Great, so here's your first problem. I'd like you to take some time, pause the video whilst I eat this lovely biscuit, and have a go at it. Use a tree diagram, I recommend, but don't have to, but give it a go. So I've had a go at writing down the question in a different way. So I've got, visually, I've got 6 green beads, I've got 4 yellow ones, or orange, but what's the probability they're both yellow? And given that, we know they're both the same colour. That means they're both green or both yellow, doesn't it? So let's start off by drawing our tree diagram. So it could be yellow and yellow, yellow and green, green and yellow, or green and green. And we just need to put in what those probabilities are as we go. So it starts off with being, for yellow, 4 out of 10. Given that they were recorded and not replaced, sometimes you have this with sweets, with them being eaten, or people looking for a pair of socks, that sort of thing. Anyway, the point is, there's only 9 beads left, and only 3 of them are yellow. And whilst there's only 9 left to have the green have got a bit more likely, because there are still 6 green there. On the other tree, you'd have 6 out of 10. Then to have a second green, you've only got 5 left, and at that point you've still got 4 yellows, so you get 4 out of 9. Now what I would do is just work out all of these for now, and that's going to give us 4 over 10 times 3 over 9 is 12 over 90, so we're multiplying the fractions here. So 4 over 10 times 6 over 9 is 24 over 90, and we don't do any simplifying. It's really important that we keep the denominators the same. 6 times 4 over 10 times 9 is another 24 over 90, the same thing, just happening the other way round. And 6 times 5 over 10 times 9, because there's more green than anything else, the most likely thing out of the 4 different things that can happen is that we get 2 greens. Although a mixture is more likely, because it doesn't matter which way round. Actually, that would give you 48, wouldn't it? Right, now we've been given that they're both the same colour. So what that means is none of this matters. So we don't have 90 possible things anymore. The possible things that we have are the 12 up there and the 30 down here, which gives us a denominator of 42. And what we want is both being yellow, and there are 12 ways it could be yellow, so that gives us 12 over 42. And if you wanted to simplify at that point, then that's absolutely fine. 6 goes in twice and 7, so it's 2 sevenths. And that's it. Pretty much. I'm just going to show you one more example where you start by being given a tree diagram that you need to fill in, and you've got a bit more notation going on. Okay? Here's your second problem. Copy it down and give it a good go, because you should know enough about probability, I reckon, to sort this out for yourselves. Give it a go, and then I'll go through it in a moment. So the first thing to do is to fill in the probability tree, and remember, all branches pair or collect together, because sometimes you could have 3 to make 1. So the probability of something not happening, if you know it does happen, adds up to 1. So 0.7 and 0.3 make 1. 0.55 and 0.45 make 1. And 0.65 and 0.35. Now the next thing I would do is get my calculator and work out all of these probabilities. So I'm going to be doing 0.7 times 0.45 for the first bit, 0.315, 0.7 times 0.55 is 0.385, 0.3 times 0.65, that's the one down at the bottom, isn't it, is 0.195. And then the least likely thing to happen is the one where we're doing the two smaller things, 0.3 times 0.35, giving us 0.105. Good idea to double check that you've got it all correct by adding all of these up, and they should come to 1. But then, having done that, it's time to look at the different things that they want us to do. So the first one is the probability of A intersection B. So that means A happening as well as B happening. So A happening as well as B happening. Remember, if we had that on a Venn diagram, it's that bit there, and you get that bit by multiplying them together. So A and B happening, we've already worked that out, is 0.315. Next one, probability of A not happening and B not happening. So that is not happening, not happening. That's the 0.195. And finally, we've got the probability that A happens given we know that B happens. Now, these are all 3 decimal places, aren't they? So we're looking at, we know the two things of B happening are this one here and this one here. So A happening when B happens is 315 over 1,000. A not happening is 105 over 1,000. Now, because those two denominators are the same, we can simply add those to make our new denominator. So that is 315 plus 105 is 420. 420 things can happen, but the ones we want to happen are these, 315. And if you put 315 over 420 into your calculator, do it just like that, adding the two denominators as you go, you do get 3/4, because 105 goes 3 times into 315 and 4 into 420. Now that is all the examples I'm going to give you for today. There's a stack of questions in exercise 2E, and I'm just going to ask you to do all the exam ones. So actually, let's not do all the exam ones necessarily. Let's do questions. Yeah, let's do all the exam ones. They don't take that long, folks, honestly. 9, 10 and 11. And if you can knock all those off without any trouble, then happy days. Right, let me know if there's any problems. See you tomorrow.